This video picks up with the second part of section 8.1, and in here what we're going to do is we're going to start looking at functions and try to get some definition of a function and what it means for a relation between two variables to be a function as opposed to just a y equals something. So we're asked to graph these. The first one, we don't need to make a table of values. For negative 3x plus 1, we know that it has a y-intercept of 1 and a slope of negative 3. So a slope of negative 3 means that it starts here at 1 and it goes down 3 and to the right 1. Down 3 and to the right 1, or it goes up 3 and to the left 1. And when we get done, we've graphed ourselves an oblique line, and it's a function. Every x value is assigned to only one y value. So pick any x value you want on this line, and it will never be assigned to more than one y value, right? Pick x equals 2, and it's assigned to, pick x equals 1, and it's assigned to negative 2. Pick x equals negative 1, and it's assigned to 4. At every x value you pick, it's going to be assigned to only one y value. All right, take a look at the second one. Second one's a little different. Second one says g of x equals x squared plus 4. So maybe we need to make ourselves a little table. And we're going to pick some x values and get out some y values. So if I pick, let's say, x equals negative 2. Negative 2 squared is positive 4. Remember, when you square a negative, you get a positive. 4 plus 4 gives me 8. If I put in a negative 1, negative 1 squared is 1 plus 4 is 5. Put in a 0, 0 squared plus 4 is 4. 1 squared plus 4 is 5, and 2 squared is 4, plus 4 is 8. All right. So each of these things are actually an ordered pair. Negative 2, 8 is the first one on my graph. So negative 2, and then 1, 2, 3, 4, 5, 6, 7, 8. There's negative 2, 8. Negative 1, 5. 0, 4. 1, 5. 2, 8. And I graph. Right, we call that thing a parabola. It's a graph of an x squared function, and every x value is assigned to only one y value. Now, the reverse on this case is not true. There are some y values that are assigned to more than one x value, but that's not what we're worried about here. So if you were to look at, let's say, a 5 over here, that 5 is assigned to a 1, and that 5 is assigned to a negative 1. So every y value is not assigned to only one x value, but that's not what we need for a function. For a function, we need every x value to be assigned to exactly one y value. The third one, h of x equals 3, is just a horizontal line here. So if I were to give the domain and range for the one in number 2, so if I were to give the domain and range for the one in number 2, the domain are all the possible x values. So let's think about the possible x values that I can put in for that red function up there. The domain is all real numbers. Any x value that I put in is going to produce a y value. There's not going to be any gaps, any big breaks in the function, nowhere where it's undefined. We're not trying to take square roots of negative numbers. We're not trying to divide by 0. Everything's good. On the other hand, what possible values can I get out? It's not going to be all real numbers because you notice everything down here is not included. Right? There's nothing down there. So the range are y values that are greater than or equal to 4. Right? 4 is the lowest y value that I can have. Any other y value on this graph is above 4. So the lowest possible y value is 4, and it goes up from there. And eventually, someday, we're going to learn interval notation, and then we'll write these a little bit differently. All right, for h of x equals 3, that's the green function down the bottom. What can I do for that? Well, the domain is the set of all possible x values. So if you look at this horizontal line y equals 3, or in this case h of x equals 3, then I can put any x value in that I want, and I'll get out a legitimate answer. So all real numbers is my domain. For the range, there's only one possible y value that I can get, and that is 3. Okay, sometimes we just might write it as a set like that, where we indicate that no matter what the domain is, no matter what numbers I input, I'm always going to output a 3. So that's how I write domain and range for functions like that. How about for questions like 4, 5, and 6? Give the domain and range. Well, for number 4, the first question is, what can x not equal? No issues on the top, but the thing down the bottom is, I can't have a 1 over 0, right? 1 over 0 does not exist. So can we find a number down here that we can't use? And so what we come up with is x cannot be negative 2. Or positive 2, rather. Because if x is equal to positive 2, I get 2 minus 2, which is 0. So that is my domain. For the range, if I start looking at possible outputs for y, I might want to graph this thing to give me an idea of what 1 over x minus 2 looks like. Okay, eventually you'll have a more intuitive idea, but first time around, let's graph it and see what we get. So I come here and I type in f of x equals 1 over x minus 2. And just like we suspected, we can't put in 2 for x because it makes the function undefined. How about possible y values? Well, look at this red function. The red function comes up and all the way here, and it gets close to 0, but it never touches it. On the other side here, the graph comes down and gets close to 0, but never touches it. Yeah, if you click on this, it'll give you some of the values. So it'll get close to 0, but it'll never actually touch 0. So what is the range? What are all the possible y values for this? The range is just y values that are not 0. Notice it can take on every other y value I want, right? The negative y values over here, positive y values up here. So it can take on every y value except for 0. So for my range, I'm going to put y values that are not equal to 0. I take a look at number 5. For number 5, it says r of x equals the square root of x. The square root of x is the square root function. Now, I don't have any problems. There's nothing I could divide by 0 because it's not a division problem. But we don't want what's under the radical to become negative. So for my domain, I'm going to say x values that are greater than or equal to 0. Because I can take the square root of 0. That's not an issue. The issue is taking square roots of things that are less than 0. So let's only include for the domain x values that are greater than 0. When that happens, what kind of numbers are going to come out? Well, y values that are greater than or equal to 0. If you take the square root of something, you'll end up with 0 or everything above it. All right, take a look at number 6. For number 6, again, we're to the issue of I don't want what's in the bottom to be 0. So if I have 1 over x squared minus 4, we said we don't want what's in the bottom, x squared minus 4, to be 0. So let's add a 4 to both sides. Take the square root. Remember, when you take the square root on this side, you put a plus minus. So x cannot be plus minus 2. Meaning that for the domain, my domain are x values as long as they're not negative 2 or positive 2. Now, I don't suspect you know off the top of your head what that graph looks like. Let's graph it and find out. 1 over x squared minus 4. All right, so that's what my graph looks like. Like we said, x can't be 2 and x can't be negative 2 because you notice that at 2 it jumps way down and then it jumps way up. So there's a disconnect there. There's a disconnect at negative 2 also. All right, in terms of range, it looks like anything greater than 0 will work for y up on the top. So y greater than 0 is a possibility for the range. It also looks like the graph crosses at a very specific value over here. Oh, negative 1/4. How can I figure that out without graphing it and looking at it? Well, if I put a 0 in here for x, I get 1 over 0 minus 4, 1 over negative 4, negative 1/4. So there actually is a gap between the origin and negative 1/4, and then from negative 1/4, everything less than that works. So for my range, I'm going to say y values that are greater than 0, not equal to, just greater than, and y values that are less than negative 1/4. That's probably one of the harder ones. And at this stage, you almost have to graph that one to see what you get. But for the domain, that's relatively easy because you can just take that denominator, set it equal to 0, and find out what values will not work. All right, so how do we figure out whether or not something is a function? We have the vertical line test. So remember I said that you have to have those x values assigned to only one y value, that like if you're filling up the gas tank, you can't have two fill-ups with the same number of gallons of the same type of gas cost different amounts unless they change the price partway through the day. If the x values don't repeat, then you can make a vertical line and it'll never intersect more than once. So that is what they call the vertical line test. One way to look at that is to see whether or not the x's repeat. So like for that first one, you've got a 1, 2, you got a 3, 4, and you got a 7, 3. Okay, so 1, 2 is over here, 3, 4 is over there, and 7, 3 is over there. Try drawing vertical lines. They'll never intersect more than one point at a time, so that first thing is a function. Look at the third one. Third one says 1, 2, 3, 4, and 1, 7. So 1, 7 is up here. Now try drawing a vertical line. You draw a vertical line at x equals 1, and it'll intersect more than one point. And I can see that because when I look at this, the x values repeat. If you have a graph, then it's easy to perform the vertical line test because you can just look at it. Right? That first one, is it a function? Yes. Try drawing vertical lines all the way through. And those vertical lines will never intersect in more than one point. On the other hand, for this one, look at that. If I draw a vertical line, it intersects here and here. So if it intersects in more than one point, not a function. Circles, ellipses, things like that, not functions. Look at letter C. Draw a vertical line. It doesn't have to intersect all over the place. It only has to intersect more than once in one spot. So if it does that, not a function. Oblique lines like letter D will always pass the vertical line test. The only exception would be if it's a vertical line. But here in part D, not an issue, passes a vertical line test. So is it a function? Yes, it's a function. Look at letter E. Pass through vertical lines. Yes, it's a function. Letter E looks like an absolute value function to me. And then letter F, yes, it looks like it keeps that same trend where you draw vertical lines and they never intersect in more than one spot. And so that's how we determine whether it's a function. If you have a table of values, you could look to see if the x's repeat. If you have a graph of a function, then that's real easy to see. Draw vertical lines. If the vertical lines intersect in more than one spot, then you don't have a function. And that wraps this up.